students, welcome to our physics class. Our chapter name is Stars and the Solar System. In the last class, we started this chapter and now we are going to continue this. Finally, we discussed about the topic, the distance between Earth and Sun. The question is, how much distance between this Earth and Sun? It is a large quantity when we are talking with kilometer. Actually, the distance is this. This much kilometer, that means 15 and 7 zeros. And how we can write this? 15 into 10 raised to 7. 10 raised to 7 means for this step it is having 7 zeros. Kilometer. That means that much huge kilometer distance is between this Earth and Sun. And this is the first star that is very near located to our Earth. Now the question is, which is the another star that is near present to the Earth? That means the next star which is near present to the Earth. Which is that? The name is this Alpha Centauri. Alpha Centauri. This is the next star that is near to Earth. And do you know what is the distance between this Earth and the Alpha Centauri? The distance is this 4 into 10 raised to 13 kilometer far from Earth. That means for this 4 it is having 13 zeros. This much kilometer. That is a huge value and the other stars are more for than this length. And when you see this, a lengthy value, and also this is too much lengthy value. Actually, this is not convenient to express the distance between this Earth and Sun with this kilometer. And we want another type of unit to represent this. That means this kilometer is not at all okay for representing the distance between these planets, stars and all. So, now we are going to study another unit that we want to express. That is the light year. Light year. Now we are going to study what is this light year and how we can represent the distance between this Earth and star using this Earth year and all. So, this is something new for you. Light year, light year. Similar to the kilometer, this is another type of unit for the distance. Unit for distance representation. Unit for distance representation. Now the question is, what is this light year? That is the question. Actually, the light year is the distance travelled by light in 1 year. So, the light year is the distance travelled by light in 1 year. That is what? 1 light year. One light year. The distance travelled by light in 1 year. Now my question is, what distance light is travelling? For 1 second, how much distance light is travelling? light is traveling 3 into 10 raised to 8 meter. That is, for 1 second, the light is traveling 3 into 10 raised to 8 meter. So, we can write the speed of light or also velocity of light. We generally say it as speed of light. So, the speed of light is 3 into 10 raised to 8 meter per second. This is what? The speed of light. That means the light is traveling in 1 second is the distance of 3 into 10 raised to 8 meter. That means such a huge value, such a huge distance the light is traveling within a second. And this light is the most speed substance in our universe now. So, this is 3 into 10 raised to 8 meter per second. So, just think how much huge quantity is this 1 light year. It is the distance travelled by light in 1 year. This is only the quantity for 1 second. So, that much seconds are there in a year. How many seconds are there in a year? That is a huge quantity. When we multiply this, we will get the value. So, no need of thinking of all these things. Just want to remember, light year is a unit that we want to represent the distance travelled by light in 1 year, and we are using this to represent the distance between Earth and the stars. So, now we are going to represent the distance between Sun and the Earth using this light year. The distance between Sun from Earth is 8 light minutes. That means 8 light minutes means what? The distance travelled by light in 1 minute. That is what this. Distance travelled by light in 1 minute is what? Light minutes. So, the 8 light minutes means the distance travelled by light in 8 minutes. That is the meaning of this. So, we are just talking about this is light minutes means the distance travelled by light in 1 minute. So, 8 light minutes means what? The distance travelled by light in 8 minutes. That is the meaning of this. So, the distance from Sun to Earth is 8 light minutes. And now we also said that other star, that is Alpha Centauri, and how much distance is between this and the Earth? The distance is this 4.3 light years. 4.3 light years. So just remember these values and want to study what is this light year, what is this light minute and all. Now we are moving to the next thing. Hope this is clear for you. We can see stars at night. This is a night sky and there is moon. Some days we have moon. And the stars are the present in our sky. And after some time, the sun arrives. Now the question is it possible to see the stars? No, we are not seeing the stars at daytime. Now my question is, do the stars are there still present or do these stars are going somewhere? That is my question. Actually, the stars are present at the sky itself at the daytime also. Then why we are not seeing these stars at daytime? Actually, the thing is this, our sun is very bright. also our sun is the very near star to our earth. Because of this reason, our sky is very bright with the light of the sun. So, it is unable to see these stars because these stars are very far apart, and that's why we are unable to see these stars with the light of the sun. If the sun is not there in the sky, then the sky is dark and we can see the stars. And also, in the night which is having bright moon, sometimes we feel some difficulty to see the stars, but if there is no moon, we can see the stars very clear. So the thing is this, with the bright light of the sun, we cannot see the stars at daytime. The thing is that the sun is very bright and also our sun is very near to us. That's why we are unable to see these stars at daytime. So you just want to know the reason. It may have the question like this. We see stars at night, not at daytime. Why? Such questions will come and this is the answer for this. Now the next question is this. You are continuously observing the stars at night. And when you observe this, have any position changed to the stars? My question is, do these stars are moving from one place to another? That is a question. We are just observing the sky, the night sky. We are just observing from 7 p.m., then 8 p.m., 9 p.m., 10 p.m. Like we are just observing at a particular direction at night. And when you observe that, you can see that these stars are moving from one place to another. I am not saying that they are moving. We feel like these stars are moving from one place to another. That means actually the motion is like this. They are moving from east to west. They are moving from east to west. What is this direction of east to west? That means north, south. This is west and this is east. That means east to west means towards this direction. So, we feel it like that. Now my question is, do these stars are moving from this east to west? I will solve this problem. Before that, I just ask you another case. Just put in mind that we feel like the stars are moving from east to west. We are coming to that point. Before that, we are just sitting in the train. This train is moving to this direction. So, what we feel, there are having some trees and all. What you feel at the background of this railway station and all, these trees are moving to which direction? We feel like these trees are moving in backward direction. When I am taking this forward, then we feels like these trees are moving backward direction. So, actually, when we are sitting in the train, we feel like these trees are running back. And we are not able to identify that we are moving. That is just an apparent feeling. The same thing happens with these stars. We know our earth is moving continuously. That means it is revolving. So, actually that makes us feel like these stars are moving. And also another example that mentioned in your textbook. Just go to a room and stand at the middle of the room. Then rotate. That means just rotate at the center of the room. When this person is moving to this direction, what we feel, the objects are moving to opposite direction. That means when I am rotating to this direction, what I feel, all the objects in this room is moving to that direction. Simply we are meaning that we are moving to a particular direction. We feel the surrounding things are moving in opposite direction. So we can say that our earth is moving from west to east. West to east. This direction our earth is continuously rotating or revolving. So because of this reason we feel that all the stars are moving in the opposite direction. That is, we feel stars are moving east to west direction. That's how we just feel it like that. Actually, not the stars are moving. Who is moving? The earth is moving and we are moving with the earth. So we just feel like when we are observing the sky, these stars are moving. That is apparent feeling. Actually what's moving? Our earth is revolving. Because of that we feel like stars are moving from one place to another. And also this is the same thing happens to the sun. We already know that our sun is at the center and the sun is not at all moving from one place to another. Who is moving? Our earth is moving. Where the sun is rising and where it is just set. Sun appears to rise in east and set in west. We just feel it like that. East to west. Why? Because of the revolution of earth from west to east. So you want to remember the earth is rotating from west to east, and because of this reason we feel like sun is rise in east and it set in west. So this is all the apparent feeling because of the revolution and the rotation of earth. So just put this in your mind that earth is rotating from west to east. This is all about this area. I hope it's clear for you. Just remember the case of the train and the things. Then you will get the proper things about this. So we just said that all the stars are moving. That means we feel like all the stars are moving. But there is one star that not at all moving, always at a particular direction or a particular space. And now the question is why it is not moving. The next one is what is its name. The things we are going to discuss. There is a star that is not moving at all. For example, we are first considering one activity. In your textbook, you can see a diagram of umbrella. One umbrella. And I am placing some of the stars here. At each point, I am just sticking some of the stars here. And at the center, I am placing one star. Now my aim is to just rotate this umbrella. What do you feel? All these stars get displacement. That means it changed its place. But what about this star at the center? That means the star placed at this axis, this line. It is not having any position difference. That is continuously rotating all this, but this is always at a particular position. The same thing is there for the star also, and now we are going to explain that. We know our earth is rotating with an axis having a particular tilt, and at this point near this earth axis have one star. Our earth is rotating with this axis means it is rotating like this. That means this point, this pole is always faced to this direction of the sky. So we can see this star all the time, and that star is having no position change, and and we call that star a name, and that is pole star. Pole star, the star that is always there at the top, that is pole star. I think it's clear for you. Nothing is there. Just remember, a star is there present at the direction of the earth axis, and the name of that star is pole star. And we use this pole star and identify some of the constellations and all. Now the question is, what is the constellation? Now we are going to discuss what is this constellation. The next thing we want to study is constellation. Constellation or constellations. What is this constellation, or we can also say it as constellations? That is very simple. We can say it as the stars. That means this constellation means group of stars. Group of stars. We are not calling all the group of stars these constellations. It is having a peculiarity, and that is the group of stars which having recognizable shape, and is called constellation. Group of stars having a recognizable shape is what? Constellations. The old people just observed the sky and they just felt the stars having a particular shape of particular thing, and they just gave names for these constellations. And now we are going to study some of the examples. There are number of constellations are there present. Now we are only studying some of the important constellations there. So in the summer early night, now we are studying about the different types of constellations. 2-3 constellations you have to study, and it is very simple. In the summer early night, you can see one star, and that name is Big Dipper. Big Dipper. This constellation have different names. That means we are calling this star different names in different locations. That's why this is called Big Dipper or Great Bear or Saptarishi, and it is also having another name, that is Ursa Major. These all are the names of one single constellation. Constellation means group of stars having a particular shape. So this is all are the name of a single constellation. Big Dipper. Dipper means spoon. Big Dipper, Great Bear, Saptarishi, Ursa Major, like the different names are there for this. Now we want to study the structure of this. Very simple. Now we want to study this. How many stars are present in this Big Dipper? You can just observe these names and identify that. Here we have Saptarishi. What means this Sapta? Sapta means 7 Saptaswarangal, that is having 7 letters. Like here Saptarishi, they just meant it as we have 7 stars. So in this constellation we have 7 stars, and the thing is like this: 1, 2, 3, 4, 5, 6 and 7. 1, 2, 3, 4, 5. So this is the structure of what? Big Dipper. That means you can see here, this is the head or the cup of the spoon, and this is the handle. So we can say there is having 3 stars here, and then 4 at this cup part. This is what they are just calling it as Big Dipper. In the ancient time, people used it to drink water in dippers. That's why they are just called this shape as Big Dipper. And also here we have 7 stars. 1, 2, 3, 4, 5, 6, 7. 7 stars are the, and that's why they are calling it as Saptarishi. And some of the people are just feeling it as a big bear, and that's why they are just calling it as Great Bear. And also it is having another name, Ursamej. This is all the thing about this. And in this section, you want to remember first the names of this. And the question will be like this: which is the another name of Big Dipper? And there you will have to see some of the structure of the stars or constellations, and you want to identify that. That means you want to study this structure. And when you see this, you want to name this as Big Dipper or Ursa Major. Like that, if you study this, then you can name it. Otherwise, it will unable to name this. That means we are going to study more structures for these constellations. The next thing we are talking is we are going to locate the pole star at night using this. And you can see this at the winter time at the night. At the summer early night you can see this Big Dipper. And using this constellation, now we are going to locate the pole star. That means the star which is not moving at all. That is what? The pole star. How we can locate this using this? It is very simple. First, we are just going to the moonless night. We are just going to the moonless night means we can see the stars very clear at that place. That's why we are just selecting the moonless night. Then we are going to the 9 p.m. 9 p.m. at night and observing the sky. And at the northern part you can see this Big Dipper. Then you just draw a line using this that we are going to discuss how we are going to locate the pole star. Locating pole star. Locating pole star. The thing is, already I said we want to go to the moonless night at 9 p.m. and when we observe the northern part, you can see the Ursa Major or our Big Dipper. It is like this: 1, 2, 3, 4. This is how we see this Ursa Major, and our aim is to locate the pole star. And towards the north, we are just considering one imaginary line. At the line joining with these two stars. You can see here 2 stars at the tip of this dipper, and we are just considering one imaginary line towards these 2 stars. And at the point you can see one star that is not moving at all, and that is what? Our pole star. And actually this Big Dipper we are looking at 3 p.m. at the 7 p.m., 8 p.m., 9 p.m., 10 p.m. Like when we are observing at different time, we can see that the location of this dipper is moving from one place to another. We feels like it is rotating. Actually, it is rotating by this pole star at the center. And that means we can see that it is moving from one place to another. And now we are going to look how the motion of this Big Dipper is. And where is the direction moves for this Big Dipper? Actually the motion is like this. It is to east to west. As the pole star at the center, we are considering this pole star at the center, and this Big Dipper is moving from east to west. That is actually the opposite direction of the rotation or the revolution of the earth. That is the thing. And now we are going to look how the motion will be there for this Big Dipper. That is a diagram and we are now going to look at. Here you can see one diagram. And here at the center, this is what? The pole star. This is what here draws the motion of the Big Dipper. At different time you can see the location of Big Dipper is changing. That means it is moving from east to west. So that means it is just moving like this. So this is the center over the pole star and it is just moving like this, and you just want to identify this diagram, and the diagram is there in your textbook at the page number 222. Sorry, 223 I hope. So this is what the motion of the Big Dipper by considering this pole star at the center. Nothing is there, just observe this. And we are not talking that there is having four dippers are there. Only one dipper is there. We are just notating this as we can see this at different time. The location is getting changed. That is the only meaning for this diagram. Now the thing we are going to discuss is the further things about this. We already said that Earth is having one axis and this pole star is at the top. Now the question is it possible to see this pole star when we are standing at this point? Obviously not. So we can say at some southern hemisphere it is unable to see the pole star. At the northern hemisphere, it's okay, we can see this pole star. When we are standing at this point, we can see this pole star is there. But when we are there with the southern hemisphere, that means when we are moving to this point, it is unable to see this pole star because it is located at this point of axis. That's why it is unable to see this pole star at southern hemisphere. We are unable to see the pole star at southern hemisphere. The next point is this: some of the stars that is located at northern hemisphere is unable to see from some points of southern hemisphere. Some of the pole star is not able to see at this southern hemisphere, but some of the other northern hemisphere stars are unable to see at some points of southern hemisphere. So just remember that some of the stars we are not seeing, we can see at the southern hemisphere. That means we are in a particular location and we have certain limit to see the stars that we are seeing at the sky. Just put that in your mind. The next type of constellation is Orion. The spelling is this: Orion. And the shape is like this. One star here, one star here, this. At the center, they're having 3 stars together. This is what? Orion. So, how many stars are there in this? 8 stars. 8 bright stars are there in this Orion. 8 stars. And the shape is like this. At the center we have 3 stars that is parallel. Parallel means in a straight line we have 3 stars. And also this is what Orion, and when we are extending this and we are just considering it as an imaginary line at a particular space, you can see another star. Something is not in this, and that star is having the name Sirius. This is another star near to this Orion. That means a star present near to the Orion is Sirius. And for this it is having 8 stars, and this is another star that is located near to this constellation. And remember, this is not included in this constellation. This is a separate star. We said for the Big Dipper, we are talking using the pole star. No, like the way we are talking for this Sirius are the domain star. That is one of the nearest star, only like that. And here the ancient people considered this as 100. You may feel it like that, I don't know. They just call it as 100. And you can see the similar diagram in the page number 224, figure 17.16. Figure 17.16. When you observe that figure, you can see that it is like a person just handy. So just observe that, and that's why they are just considering this as 100. That is actually a huge imagination. You may not feel like that. And they considered these 3 stars as the belt of the 100. Belt of the 100. Nothing is there. Just remember and read all these things. And want to remember, the Sirius is one of the brightest stars located near to the Orion. And this is all about this. In this area, you want to remember the name Orion, and you want to identify the structure of this and remember the number of stars present, and also want to know there is 3 stars parallel, and when we elongate the line of this parallel stars, you can see another bright star, and that is called Sirius. These are all the things we discussed in this region. And the next also we want to study another type of the constellation, and another type is this Cassiopeia. Cassiopeia. This is the next type of constellation, and we can visible this at the winter early night. Winter early night. We are saying this early night because we know our earth is rotating, and after some time it will move to the further line. That's why we are just saying that we can see this as the winter early night. So the shape of this is like 5 stars are there. It is something like this shape. So we can say it as, this look like a distorted letter M or W. This is similar to some English letter M or W. So what? This is Cassiopeia. So you just want to remember the name of this Cassiopeia and remember the number of stars present, 5 stars. 5 stars. And also, what is this? The diagram or the structure is similar to a distorted English letter M or W. Just remember these things. This is only about this. Remember the name, remember the structure, and remember the number of stars. This is all the thing about this. The next topic is this, the solar system. Solar system. Very simple thing. The constellation is over there. That means the group of stars, and you want to remember the 3 types of stars. So, what is this solar system? Solar system is a system where the sun present at the center, and all other celestial bodies that revolve around the sun. All celestial bodies means the planets are there and asteroids, like all the things are just revolving around the sun, and the whole set we are calling what? Solar system. Now we are just going to study what are the things included in the solar system. Sun is there. Sun means the star. So then next, planets are there. Planets, comets. Comets means the stars having a particular shape. Asteroids, meteors, like different types of celestial bodies are present in a solar system. Now, my question is, why all these are getting in circular motion and why they are not getting clumsy? That means why they are not going to other position and they are continuously rotating in a particular orbit. What is the reason for that? The reason is this: it is gravitational force. Gravitational force or gravitational attraction. That means within these celestial bodies, it is having certain attractional force, and that is gravitational force, and you will study in this detail in your 9th standard. So just remember that the reason is this, the attractive force, and that is called gravitational force. The next thing is that our earth is also revolving around the sun, and we are also revolving around the sun with this earth. Now we want to study the names of these planets that rotating and revolving around this sun. In the solar system, the sun is at the center. Other planets revolving around sun. And now the question is, which is the nearest planet and which is the next planet? Like, we want to study the order of the planets and also want to study the names. Now we are going to study the names. Before 2006 or till 2006, we have 9 planets. Then the definition of planets got changed and one of the planet got expelled from the list, and now we have 8 planets. I already said that the order is important. So I am going to give you something to remember the order of this. My very educated mother just shown us 9 planets. There is something why I draw something here like that. I will tell. The first one is, the code is this: my very educated mother just shown us 9 planets. When you remember this, you will be able to say it very easily. That means the first one is Mercury. Mercury, the first planet near to Sun. The next we are talking about the planet next to this. Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and actually now we have only these 8. And before this 2006 we have 9 already said, that is Pluto. This Pluto had gone, so now it is not considered as a planet. So this is the 8 planets, and this code is that before this 2006, and that's why my very educated mother just shown us 9. And there is a planet, and that is Pluto, but now it is not the planet. And when you are studying this, just remember that this Pluto was a planet, now it is not. And so just remember the name Pluto. And this is very farthest and it is very small planet. That's why it is just got out of this. So this is the order my very educated mother just shown us 9 planets. So Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. So you want to remember the names and the order. For the next class, you want to remember the names and the order, and we will discuss each and every planet in detail in the coming class. It's enough for today. You please want to read your textbook 3-4 times. There are so many things that explained in the textbook. So just read it and want to complete your notes also. And we will meet in our next class with the explanation of these all planets and all. It's enough for today. Thank you.